Okay, so 4.4 centre of mass. So in the previous lesson, we saw that every single thing we were sitting on was uniform, whereas now we have a non-uniform plank. Now, if something is non-uniform, it means the centre of mass is somewhere else, not in the middle, right? And like thinking about it practically, why would that be? I don't know. You've got different density in the material. Maybe half of your plank's actually made out of wood, the other half's actually made out of foam. Some sort of inconsistency in the building of the plank. Any consistently built plank of the same material would have the same density throughout and would therefore be uniform. You don't need to worry about that though. You don't need to worry about why something might be non-uniform. This is maths, so all we need to know is that if it says it's non-uniform, it means that the centre of mass is somewhere else and we need to calculate where that centre of mass is. So in this problem, this is a lovely problem because we're now dealing with a seesaw, and I'm sure you all love seesaws from your childhood. So this will hopefully bring back lots of memories of joy of playing in the park, which obviously you're not allowed to do at the moment. But instead we can do some mechanics problems about a seesaw. So let's have a look. The mass is 25 kilograms, the length is 4. We've got the Tamsin is sat at A, having a great time, and she weighs 25 kilograms. That seems small. I guess probably as a child. So if she's sat at A, we've got a force of 25G coming down from here. Here's Sam. We've got a force of 35G coming down from here, but we don't know exactly where he's sat. We've got a reaction force, obviously, coming up from the middle, which we'll call R. It told us where the centre of mass is. Its centre of mass is at 1.8 metres. So it's not in the middle because it's a 4 metre plank. So at C, we've got a force of all of the weight. So wherever the centre of mass is, that's where we model it as having the weight coming down. So there's, let's see, what is it? The mass is 25 kilogram. So again, that's 25G. And all we're trying to find out, we don't really care for the reaction, although we can calculate that if we want, is this distance here. We want to know how far he is from the end. So if we call that X, and that's the thing that we're trying to find, it asks us where he must sit for the plank to be horizontal. By being horizontal, it means for it to stay in equilibrium. So even though it's not said it's in equilibrium, for it to be horizontal, it will only be horizontal if it's acting in equilibrium, and those two weights are balancing each other out. So let's have a little look at what we can do. Same two options available to us as always. Either we resolve it vertically, and actually you can see if we resolve it vertically we'll find out what R is, because R will have to balance with 25G, 25G and 35G. So that is an option if you wanted to find R, but nowhere does it ask us to find R. But you know what, let's do it anyway. Why not? I'll just demonstrate it. I know it's not going to be any use, but we'll still do it. So we've got resolving vertically, R is 25G plus 25G plus 35G. Right, this is 85G, which is the value of R. That's the first option, resolve vertically. The second is to take moments about somewhere. Now again, you can take them wherever and you were still going to get to the answer. What I'm going to do is I'm going to take moments about M. Reason for this is because I've already said that X is going to be the distance from M to Sam. So that's really easy because when I do my distance it'll be X. I don't have to do like 2 minus X or anything like that, or 2 plus X, right? I'm just going to use X. And it is an actual pivot point, isn't it, right? It's an actual pivot, even though you can do it from points that aren't a pivot. So you could take moments from A if you wanted, even though A is not a pivot. It's a natural pivot, so it seems to make more sense. So what we have to do is we have to think about each of these forces. We know that R is at that point, so it won't act on it. And remember, if we've got a pivoted, so I'll use my pen, if we're pivoted there, these two forces pulling down on the left are going to move it, which way are we moving there? We're moving anti-clockwise. This one, even though it's close to the pivot point, still going to move it anti-clockwise. And then this guy on the other side, pull it down, that's where you get the clockwise movement. So we've got 25G are both anti-clockwise, and the 35G is clockwise. So let's start with those anti-clockwise forces. So the first one that I'm going to do is this 25G here. We're taking M as the pivot, remember? Right, so we are 2 meters away from M because M is at the middle. It tells us that M is the midpoint of AB. So it's 2 times 25G is 50G. The second one is this one here. It's 1.8 meters away from A, which is going to make it 0.2 meters away because the full distance would be 2. So 0.2 times 25G is 5G. So they are my anti-clockwise. Meanwhile, the clockwise movement is this one here, which is the X distance away from the pivot and is 35G down. So it's 35Gx. And that's the only one acting in a clockwise direction when I take moments about M. So, what do? We know it wants to be horizontal, or that's the point. So where should he sit? How far away from the M should he sit? Well, we need them to be equal, so it's 50G plus 5G. There, the anti-clockwise is equal to the clockwise one. So this is 55G equals 35Gx. You can see I can divide through by G. That's why I didn't put the 9.8s in, because they were going to cancel. So X is 55 over 35. God, they didn't make it nice for us, did we? So this is going to be 1. Better get my calculator. 55 divided by 35, 1.57 meters. Right, that's X. Now remember though, they didn't ask us to find X, they asked us where should Sam sit. So if Sam asks you where should I sit on this plank so that it doesn't tip, and you reply X is equal to 1.57 meters, that's not going to be much use to Sam, right? Sam's probably a 6-year-old child. So where do we want him to sit? We want him to sit 1.57 meters from M. So our final answer needs to tell him exactly where. 1.75 meters from M. Okay? So you could write that alternatively. You could write how far away from B he would be. He'd be 0.43 meters from B. You could write how far away from A he needs to sit. He'd be 3.57 meters from A. But you must specify where you're measuring from whenever you give your distance as a final answer.